And now I'd like to welcome up to the stage the host of Planetary Society's Planetary Radio, Matt Kaplan.
Okay. Welcome, everybody. We can start now because my wife and mother just got here. I've heard already about the bad accident on the 210. Who had to deal with that? Apparently, that's why people are still just trickling in as we speak. So we're at almost 4:59. Are we already streaming, Dave? We are up. So hello also to the online audience. This is the preview introduction to the show. We decided to go ahead and get started, especially with the online folks in mind. Thank you to all of you who are here live in person, and thank you to everybody who's watching the webcast this evening. It is going to be an exciting evening, not just because we have such great people to talk to here and at APL, which you'll be hearing more about in a couple of minutes, but because of the big event that is right now about an hour and 10 minutes away. And we'll be talking about that as we get into the evening. So basically, I'm killing a couple of minutes now until we can get to 5 o'clock so that the people who show up for the online, for the live stream, won't really miss anything. What's going to happen is we're going to open with a music video. And it's really cool. I mean, I watched it for like the third time this morning, and I was almost in tears. So we're going to open with that, and then we'll come back to me, and then I'll do the real opening for the show. Again, thank you all for coming out. And Dave, I think we can roll that anytime now.
Hi, Pluto. Hi, Pluto. Hello, Pluto. Hi, Pluto. Say cheese. Hi, Pluto. Hi, Pluto.
Hi, Pluto.
Hi, Pluto. Say cheese. Hi, Pluto. Hi, Pluto.
Hi, Pluto. Hey, Pluto.
Hi, Pluto. Hi, Pluto. Hi, Pluto.
Hello, Pluto.
We are your distant neighbors from the planet that is blue, and we're coming for a visit with the hope of knowing you. You may have felt the buzzing as we've studied from afar. We take a special interest in all that shares this yellow star. Pluto,
Hi, Pluto.
you'll know
Hi, Pluto.
soon. Oh, Pluto, you'll know who we are.
Hi, Pluto.
We are the beings who render designation. We strive to do our best with our grit and innovation. We test our many theories, climbing over, crawling under. We're full of good intentions, curiosity and wonder. Pluto,
Hi, Pluto.
you'll know
Hi, Pluto.
Hi, Pluto.
soon.
Hi, Pluto.
Oh, Pluto,
Hello,
you'll know who we are.
Greetings, Pluto.
Pluto, you'll know
Hi, Pluto.
soon.
Hi, Pluto.
Oh, Pluto, you'll know who we are. We're sending out a vessel that is smart and true and sturdy. It carries forth the mission beside Clyde from 1930 to figure out the universe for woman and for man.
Hi, Pluto.
To grow our understanding, to learn all that we can.
Hi, Pluto. Hello, Pluto.
Pluto,
Привет, Pluto.
you'll know
Hi,
soon. Oh,
Cześć, Pluto.
Pluto,
Czekać.
you'll know who we are.
Hi, Pluto.
Pluto,
Hi, Pluto.
you'll know soon. Oh, Pluto, you'll know who we are.
Hi, Pluto. Hi, Pluto.
Hello, Pluto. Pluto, Pluto.
But Pluto is the last planet?
Yes.
Is
yeah.
it, in Spanish it's Plutón.
Oh, really?
Yeah.
Oh, I didn't know. Okay.
Hola, Plutón.
Was that great or what? Welcome to Planetary Radio Live. On the night, we hear from Pluto. Let's hear it. So that sweet little tune that you just heard and watched is Oh Pluto from Craig Worth and Christine Lavin, and you can see it on YouTube. I'm Matt Kaplan of the Planetary Society, host of the Society's weekly public radio and podcast series. We are in KPCC, Southern California Public Radio's Crawford Family Forum with outstanding special guests and a room full, this is you guys, of thrilled Plutonians. Let me hear again how thrilled you are. So we will also soon hear from the Society's senior editor and planetary evangelist, Emily Lakdawala, and possibly from Planetary Society CEO, Bill Nye the Science Guy. Both are at the next best place to Pluto itself this evening, and that's the Johns Hopkins Applied Physics Lab outside Baltimore, Maryland, which is the control center for the New Horizons mission. Hundreds of guests and media representatives are there right now, anxiously waiting, as we are, for the terribly weak radio signal from the probe that will tell us that it has completed its historic encounter. There will be no new pictures tonight. I hope everybody got that word from other media and maybe from us, maybe from Emily's blog or tweets. And those reasons for that will be explained, I'm sure, over the course of the evening. But we do have a spectacular image taken by New Horizons just yesterday, Tuesday, July 13th, when it was barely three-quarters of a million kilometers, that's less than 500,000 miles, from Pluto and its neighbors. And we can bring that up now, Dave. I think. There it is. So what you're looking at, it's sort of a composite. The color is coming from a different instrument on Pluto, but that's not false color. As far as they know, that's fairly accurate color of this planet, dwarf planet, call it what you will. That may also be something that we will talk about tonight. It is beautiful, but it pales compared to what we hope to see in a few hours. Back here in Pasadena, California, 3 billion miles from Pluto, let's go ahead and meet those special guests that I was just talking about. The first is my Planetary Society colleague, our Director of Science and Technology, who joins me every week for our What's Up segment. Please welcome Bruce Betts. Welcome back.
Thank you. Good to be back.
Also joining us this evening is the best-selling author of, and I'm going to pull it up here, Postcards from Mars, and his terrific new book, which we actually talked about on the radio show a few weeks ago. It's called The Interstellar Age, Inside the 40-Year Voyager Mission. He is the professor and planetary scientist at Arizona State University who is already preparing the main cameras for the next big Mars rover. And he happens to be the president of the Planetary Society. I call him the Ansel Adams of Mars. Please help me welcome Jim Bell. Thank you, Jim. Now, as we look toward Pluto this evening, we look through the orbit of what is many people's choice for the most beautiful planet in our solar system, other than our own, which a lot of us are partial to. Right now, something like 1 billion miles away, the Cassini spacecraft continues to return awe-inspiring images and science data, just as it has for the last 11 years. As Cassini's project scientist, our next guest oversees and coordinates all the work underway by hundreds of researchers around the world. She has been with the mission since before its launch, nearly 18 years ago, and she also holds the record for the most appearances on this program, Planetary Radio. Please welcome Linda Spilker. All right, thank you all three of you for joining us this evening. I think you're prepared to give us a little bit more of a detailed introduction to this mission.
Yes, it will be a detailed, really fast introduction. Picture the flyby part of the mission, not the 9.5 years getting there. So let's go ahead and pull up the first slide on that when you're ready. So the Pluto is a system. Again, I'm just going to give you a quick overview. It lives out in land called trans-Neptunian objects, usually beyond Neptune. It was discovered in 1930, has a 6.4 Earth day rotation period, or Pluto day, and a whopping 248 Earth year to go around the sun. It currently has 5 known moons, including Charon, which is pronounced various ways, Sharon, Karen, and that is a significant fraction of its size. And you can see some of the other trans-Neptunian objects, some of which might have been discovered by someone in the audience. And then you can see a comparison at the very bottom to the size of the United States of both Pluto and Charon, so they both would basically fit within the United States in terms of their diameter. Next. This, again, Pluto almost right smack in the middle of this, showing other objects. So smaller than a lot of the large moons of the solar system, certainly smaller than Mars, Mercury, larger than a lot of other stuff in the solar system. So kind of fitting in a mid-range. But yeah, let's go on to the next one. Sorry, we're clipping through these. And the guests, we can always, I partially put a lot of slides in here so we can come back to them if we want to reference. This a just released montage from our colleague Emily Lakdawala, where you can see Pluto and Charon with the current images down in the lower mid-right. And notice compared to the lower right series that Pluto and many of these trans-Neptunian objects are all significantly larger than the largest asteroid, Ceres. Next image. Triton, up until the last few days, was the best analogy for Pluto. Now Pluto's the best analogy for Pluto. Triton is the moon of, large moon of Neptune, and thought to be possibly a captured trans-Neptunian object or Kuiper belt object, and we can talk more about that later. And also covered with various exotic ices, including nitrogen, methane ices, and other stuff that we find on Pluto and Charon, at least some of it. Next. This really, the point of this is it was a very long road politically and technically, mostly politically, to get a mission to Pluto. And that's something that the Planetary Society played a key role with in getting its members and the public actively involved in trying to lobby for mission to Pluto. And that's what, after various permutations, stops, starts, cancellations, what became New Horizons, and now the success that we see. Next image. So here we can talk about these as needed, but basically these are the different instruments, science instruments carried by the Pluto, the New Horizons spacecraft. It is basically a small spacecraft that was put on a giant rocket to try to get it going as fast as possible towards the outer solar system. And there are imagers and spectrometers and radio science, dust counter. Next image. So that's me at with the New Horizons, the rocket Atlas V that launched it on the left. I was there for a couple days and they had problems and couldn't launch it. They asked me to leave, and then you'll see they had a successful launch in the lower right.
That's a habit with you in the Cape, isn't it?
Yeah, I've done that many a time. Thanks to me, the Mars exploration rovers also made it to Mars. Next image. So here we have, in a clean room, the actual New Horizons spacecraft, as well as their kind of logo being assembled. Next image. It is powered by a radioactive power source, radioisotope thermoelectric generator, as all outer planets missions have been. And here you see the trajectory, an overlook from above, so to speak, the plane of the Earth's the solar system, and the 9.5-year trajectory in green, and where New Horizons is now, right about Pluto, and then the continuation. Next. So again, a lot happened. A long time to get to Pluto, nearly 10 years, In about a year after launch, they encountered, they did a flyby of the Jupiter system, took some very nice data as they zipped through their first mission to fly down the magnetotail of Jupiter, and then a lot of kind of hibernating and practicing for what happened today. Next image. How long does it take to get? Well, it's a long time. It's 9.5 years, and partly to emphasize that, Planetary Society with New Horizons put together a time capsule, a digital time capsule. These were some of the images people submitted along with captions that make them make more sense in 2006 of what might change now. You can find that on our website in a blog of mine from a week ago. Next image, let me show you what happened in my life in the time it took to get to Pluto. And by the way, the suns are reversed in the two images. One of them is here this evening.
Right there. Stand up. Wave to him.
That's Kevin. Yeah. So especially in certain lives, it's a long time, and that's trying to get there quickly, complete with gravity assist. Next image. This is the flyby that happened this morning. This is to demonstrate it occurred about 1 Earth diameter from Pluto. That's how close, at 4.77 billion kilometers away, that's how close it flew, about 12,500 kilometers. Next image. And this is how it went through the system of Pluto, including the 5 moons. Next image. And here we get into some real genuine data. And so here we have Pluto and its moon Charon, roughly to scale, Charon being about half the diameter of Pluto, and looking different, darker, and Pluto redder, and we can talk about that with our experts later on. Next. So I couldn't do this without showing some of the data we got here. If you watch, there's a circular feature, probably a crater in the middle here, and you can see it rotate around as New Horizons gets closer. Next image. And it's moving over, and then as they get ready for the flyby, next image. And we saw this, as Matt showed, the nice color, mostly real color image that was the last one returned before the close flyby. We'll be getting data over months and years to come. And then, of course, the reason that it's named Pluto, next image, it just kind of worked out. It's actually the dog that was named after the planet, but that's another story. Next image. This is Charon, its moon, and you can see the dark polar region in the top. And next image, I think is the last data image, we have just a little higher resolution. And next image, oh right, which is I'm sorry. They released a false color today where it's through actual color filters, but they assign false colors to it to emphasize the color differences, which tie to some type of difference, probably material on the surfaces of the bodies. Next image. And this is the future for New Horizons. It spends the next weeks, months, and even a year to a year and a half sending back data, but it is going to try to target another much smaller Kuiper Belt object, yet to be determined which one, in a few years, probably in the 2018 to 2020 timeframe. Thank you. Good night.
Well, almost. We're not quite done with Bruce. How many of you have seen any episode of his Random Space Fact video series? Quite a few.
If you haven't, just pretend you have and raise your hand anyway.
And well, you get to see one in a moment here. We also, of course, have a Random Space Fact every week as part of the What's Up segment that Bruce does with me, the only other person who's been on every episode of the show for nearly 12 years. But you do have a couple of Pluto ones. We have time to show you one tonight. It's only about a minute. And so I think we'll go ahead and do that now. Is there anything you need to say about it first?
Nope. Self-contained.
Roll it.
Random Space Fact!
The New Horizons spacecraft set a record when it left Earth at the highest speed of any human-made object, over 58,000 kilometers per hour. Still, it takes 9 years to get to Pluto. But at the speed it left Earth, you could go from Pasadena, California to New York City in 4 minutes.
Whoa! Hey now, watch it, buddy.
Only in New York, am I right?
So there's your sample of random space fact, and there is one of those almost every week. Jim, your new book, The Interstellar Age, you trace the magnificent voyages of Voyager 1 and 2. What do those venerable ships have in common with this new interstellar travel?
Yeah, so Voyager 1, Voyager 2, Pioneer 10, Pioneer 11, and New Horizons are the only 5 objects that are leaving our solar system. Out of all the things we've launched around, they have enough acceleration to get beyond the sun's gravity, and they are going to be orbiting the Milky Way with the sun for forever. I was struck because we've been waiting for these pictures and other data since the 1960s, right? I mean, when I was researching this book, I found out, I was reminded that there was a plan, actually, the missions that became Voyager 1 and Voyager 2, there had been a plan for one of them to be a Jupiter, Saturn, Pluto flyby, and another one would be a Jupiter, Uranus, and Neptune flyby. And so we could have seen, if that had come to pass, we could have seen Pluto in the 1980s with the Voyager cameras. Didn't come to pass. We ended up doing a different kind of grand tour, Jupiter, Saturn, Uranus, and Neptune, and having to wait another 20 years for these spectacular images to come back. I think it's been worth the wait, and it's just really exciting to see this all happen.
Absolutely. Linda, all those missions that Jim just mentioned, plus yours, plus a few others that have made it out to the outer portions of our solar system, so-called, I imagine they've taught us all there is to know about the outer solar system, right? He said with feigned innocence.
Oh, absolutely not. I think every time we fly by a new world, we get a different, an expanded vision of the cosmos and our place in it. And Pluto is no exception. It's looks like a little bit like a lot of different worlds. And when you put the pieces together, it'll be so fascinating to find out what it contributes. The origin of the solar system. How did the solar system form? How did we get here? What's so special about where the Earth is in the solar system? Pluto holds some of those answers, I think.
Let me, for any or all of the three of you, just from the images we're seeing so far, aren't there some pleasant surprises there? I mean, it's a pretty cool world.
A very, very cool world. I mean, this is the last time, Matt, that all of us will see a place that all of us have heard of go from a little dot to a real world. And then there's really geology there, and we'll probably find out there's meteorology there in that thin atmosphere, and maybe a very active interior in the past, or maybe even today. Maybe we'll see geysers. Maybe we'll see strange cantaloupe terrain, like on Triton, that picture that Bruce showed. Who knows what we're going to see? But we're all discovering it together. It reminds me in some ways of what happened with Voyager, right? With Uranus and Neptune going from dots to real worlds. But for that experience, that was in '86 and '89, there was no internet. We couldn't share it all. The entire world is now sharing this experience of going from that dot to real worlds.
Anybody else want to get in? Linda?
I remember for the Voyager flyby watching as Neptune's moon Triton went from a point of light to a world, just like we're seeing with Pluto, and just staying up and watching each image as they came back. And we didn't have the internet, but everybody there at JPL for the Neptune encounter watched in awe as those pictures came back.
Yeah.
I was at Planetfest, Planetary Society Planetfest, 1989, watching Triton come in and and currently in graduate school studying planets and going, what the heck is going on with that weird thing? And that's part of what's so exciting is that we go to new places. We see almost every time we see somewhere new, better, more up close and personal, we discover things we didn't expect.
We are going to jump out in a couple of minutes and talk to Emily Lakdawala, if all is well, at APL, the Applied Physics Lab outside of Baltimore, where the mission is being controlled. She's there with a lot of other people. But first, Bruce, and if anybody else wants to jump in, please do. Why no pictures tonight, damn it?
You're so belligerent.
Damn straight, yeah.
New Horizons spacecraft has a fixed antenna, and so to point the antenna to send data, receive data from the Earth, you have to turn the spacecraft. The plan is after 9.5 years, you've got a very small window of time when you're going tens of thousands of kilometers per hour whizzing by that you want to take all the data you possibly can as you're going by. And that's why there was this halt of some 21 hours, I think, of no communication whatsoever because they focused entirely on getting data. And then, and plus, I don't know whether you knew this, but Pluto is really far away.
Oh, that explains it.
So it turns out it takes a really long time to send back the data, and even the data they'll often send compressed or smaller images initially. Well, they'll be coming back over the next few days.
Linda, do you have to do this kind of, gather the data, send it back, gather some more data, send it back?
Cassini is the same way. All of the instruments are bolted on the spacecraft, and so we use our time in close to Saturn to look at all the different targets and then phone home and send the data back to Earth. So we do exactly the same thing.
I wonder if people appreciate, Matt, the drama right now, okay? This spacecraft went through that system. You saw the bullseye pattern, right? And we don't know if there are faint rings that we didn't see, debris, stuff coming off of some of the other moons. It could have slammed into a grain of rice and been vaporized. We just don't know. And that's what we're waiting to find out. And I'm not on the mission team. I'm an interested observer, colleague of many of the people on the team. I've got butterflies in my stomach. I'm getting a little bit antsy. I can't even imagine what it's like for the people on the team who've invested a decade or more of their lives for this one critical moment where it all has to go right. Everything has to work perfectly. And so I can't wait for it to end.
Well, I'm just hoping that Principal Investigator Alan Stern is sedated or something.
Yeah, really.
Because he must be going nuts. We are now less than 45 minutes from actually finding out if New Horizons did what it was supposed to during that close encounter, because there is this little bit of a signal, a few little bits of data that are going to come back from the spacecraft to tell us, yep, I made it, or there's no spacecraft anymore. Maybe it hit that grain of rice.
It's unlikely that it will communicate that.
It probably will not. And in fact, that's important to mention, actually. If we don't get a signal, it doesn't mean that some catastrophe has happened.
Right.
It could mean many, many things, and it'll be probably days before they figure it out. So let's not think the worst. Let's be positive.
It's a smart robot. Hopefully it'll know what to do up there. All right, we're going to go now.
That signal passed the orbit of Jupiter about 10 minutes ago.
Oh, that's good.
Just, little random beacon facts.
What's the light time from Pluto to here right now?
4 hours and 25 minutes.
4 hours and 25 minutes. Not bad. Damn that Einstein. Let's go now to that Skype connection that I was talking about. We're going to be talking to the Johns Hopkins Applied Physics Lab, and that is where our colleague, Planetary Society's senior editor, Emily Lakdawala, is anxiously waiting for the big moment that is minutes away. Good evening, Emily, and who's that guest you have next to you?
Hi, guys. And actually, the first and most important greeting I have to make is, hi, Anahita and Sanaya. I hope you're there in the audience. I miss you guys. And here we are at the Applied Physics Lab. I can't believe I made the mistake. At the ready for Pluto flyby. It
Take
is
two.
so exciting to be here.
So there's just a lot of people, over 1,000 people in this auditorium. Very excited to get these couple of signals, these handshake tones from way the heck out there. So, I don't know, we just joined you, as you may know. Did anybody talk about the Planetary Society and Senator Mikulski?
Not by name, but Bruce did talk a little bit about the advocacy role the Society had. I'm sure that our Director of Advocacy, Casey, would be thrilled if you would talk about that a little bit more.
So I, as your humble Vice President, in the year 2000, went to Senator Barbara Mikulski's office, and the Applied Physics Lab is in her district here in the her state of Maryland. And we had 10,000 postcards from you, from Planetary Society members, and it was compelling. And Bill Frist was there, who was a representative from the House of Representatives, and she was a senator. She's retiring senator. And we, I think, made a pretty good case. So about 2 years later, a little less than that, they started building the mission that came to be called New Horizons. And I was down at Cape Canaveral in 2006 for the launch. It was January 19th. 2006, and 9.5 years later, this thing got there. And, you know, everybody, did you talk about the money too? Did we talk about that? It was $750 million. Over 15 years. Everybody, you've spent more on coffee this week than you did the last 15 years on New Horizons.
Not any of you individually, but you get the idea.
No. I mean, in other words, the cost per taxpayer over the last 15 years is less than a fancy cup of coffee. And this is the extraordinary thing you can do. So this is why we at the Planetary Society are so strongly, we work so hard to advocate strongly for planetary missions.
Bill, Emily, have you talked to any of the New Horizons team members? I mean, how are they tonight? I mean, I was joking about Alan Stern really ought to be sedated probably about now.
Well, they are very excited. And can I tell you a little bit about the geology of the first picture?
That was my next question for you. Please do. Emily is a geologist, by the way.
It is so absolutely amazing. So we look at this global disk image of Pluto, and it is an incredibly diverse surface. You look at the pole, it looks like one thing. You look at the heart. The heart is actually two different kinds of terrain. There's carbon monoxide ice in one place, and there's some other kind of ice in another
the heart,
place.
we have the image up now. That's this big, whiter or lighter area, right?
That's right, and they talk about the left ventricle and the right ventricle, and the left ventricle is the one with the carbon monoxide ice. And then next to that is the dark region now called Cthulhu, which is this very dark material that looks a lot like Iapetus. That's actually, for me, the most familiar thing about Pluto, is that this material near the equator looks a lot like Iapetus. And then you see some linear features that could be tectonic, they could be crater-related, who knows?
Could be ice cracking.
Could be all kinds of stuff. So there is so much geology just in this one image, and that's just the first close-up image we've gotten.
It's going to get 1,000 times higher resolution.
It's going to get, yes, so much better. Tomorrow we should get a whole lot of well, not a whole lot, 3 high-resolution images that show us what the surface looks like across that heart. So we'll be able to see that in high resolution.
So it's nitrogen snow and nitro tar.
Nitro tar. That sounds like something you'd put in a hot rod. Emily, how long is it going to take to get all of the data back from this flyby?
16 long months. However, those of us who are image fans will get to enjoy the entire image data set in about 2 months after the flight, actually a little bit longer than that. November of this year, we'll get all of the images back in a compressed format. They'll be JPEG compressed, they'll be kind of mungy around the edges, but we'll still be able to appreciate what they look like. Then they're going to retransmit everything in a lossless way, and we'll get the whole data set by the end of November 2016.
All right.
2016.
Yes.
As I look at the clock on the wall, we've got about 37 minutes before the big announcement. How is that going to come to us, assuming that data is received?
Well, they'll get the carrier signal first, just the tone that they recognize the frequency signal coming from the spacecraft. Then they'll get lock on that carrier signal. They'll lock up with the phase of the transmission, and then they'll start getting these frames that tell them the health of the spacecraft. We'll get little bits of information about temperatures here and data rates there and what they're doing in the particular science sequence. We won't get any images tonight, but we will be able to determine that the spacecraft is going through its science sequence as planned. So that's what we hope to see tonight.
Yeah, if it hits that piece of rice, you won't get these data.
You heard that.
Yeah, but if it doesn't.
I said you heard that.
Yeah, we heard it, yeah. If it doesn't hit anything, no invisible rings and so on, the place is going to go nuts because they've been talking about this, well, I guess for months. This handshake, the handshake moment, and how this is really the thing that's going to reassure everybody that the thing was operating perfectly as it went by Pluto. It's really a big deal.
And I'm sure people are going to go nuts in here, too. I expect them to. I know I'm going to. Emily, we are at least, a little preview from Bill. Emily, we are definitely going to talk to you again at about 20 minutes after the hour. Bill, if you're free, please feel free to come back and join her, and hopefully we'll have something to celebrate.
Yeah, we are very excited, everybody. It's really cool. I mean, I, in a sense, have been messing around with this mission. I mean, in my ancillary way for 15 years. So this is really an exciting day.
And how?
Thank
you both.
Anybody else love Emily's Planet Pluto shirt?
Oh, yeah, show us the shirt.
Nice.
That's really the best. When they tried to make new Pluto, it was nothing.
Yeah, really, it just didn't hack it, right?
Yeah.
Emily Lakdawalla, oh, go ahead.
throw this in. Just thank you, everybody, for coming to this event in Pasadena and supporting the Planetary Society. We were advocating for this mission 15 years ago, and currently we are advocating for a mission to Europa, which is, I believe, not to pit one against the other, but a place every bit as interesting as Pluto, with twice as much seawater as the Earth, and who knows what's down there. And the only way to find it is to send a mission out there, and through your support, we have been very successful in our advocacy. We saw Ellen Stofan tonight, the chief scientist at NASA. We saw John Grunsfeld. They're all very excited about the instrument package that's going to go on the Europa mission. And we are able to do this because we are able to have full-time political analysts and advocates in Washington, D.C. especially. So thank you all very much.
Yeah, thanks to our members and donors. Emily Lakdawala, Bill Nye the Science Guy. We will check in with at least one of them a little bit later. Let's hear it for them. All right, we're going to go back into a little bit of discussion just here in the room for a little while. At about 6 o'clock tonight, Pacific time, we will cut over to the NASA webcast and watch as they watch and wait and hope for that big moment at about 9 minutes after the hour. But in the meantime, folks, let's get to the elephant in the room, okay? We all know that the International Astronomical Union, the IAU, decided to downgrade Pluto from full-fledged planet to dwarf planet in 2006. Now, doesn't this cast a little bit of a shadow over this evening? I mean, if
Matt, come on. This is more interesting as the first object that we're seeing, the Kuiper Belt. Who cares that it's not a planet anymore? It's more interesting now than it ever was when it was just this mungy planet at the edge of the solar system. It's a great object to go see. I love Pluto.
Well, okay, then I stand corrected. And I stand corrected by Caltech's Rosenberg Professor of Planetary Astronomy. He has been awarded Caltech's Feynman Prize of Feynman Award and the Kavli Prize in Astrophysics. He is also, give me a moment here, because this is going to give it away, the best-selling author of How I Killed Pluto and Why It Had It Coming. Please welcome Mike Brown. That was fun, Mike. Thank you for putting up with our little bit of shtick there, and especially thank you to you for putting up with that. I only decided to invite you to this party a couple of weeks ago. You were on vacation, not checking email, so I'm really glad that you got back to us and you're able to join us tonight.
I came back just for you.
Thank you, Mike. And you're headed from after this back to Thailand or something like this. Okay, first question, level with us. Do you really love Pluto, or are you just saying that to stop the hate mail?
No, when New Horizons was first being talked about, when missions to Pluto were first being talked about, I thought it was kind of exciting to go visit the last planet and to see this oddball at the edge of the solar system. But I'm so much more excited now to get our first chance to visit the Kuiper Belt. For the last 15 years, I've been studying these objects out there in the outer solar system, been finding these big ones that are like Pluto, and now we get to see one for the first time. And every hour that I'm seeing new images of Pluto, it's sort of changing my overall impression of all these objects in the Kuiper Belt. So I'm as excited as anybody about this mission.
Let me just hold up the current issue of Popular Science. He's got an article in here. It's called Why I Still Love Pluto. It's a very nice piece. So he's definitely making amends, everybody.
Trying.
How many worlds out there have you had a part in discovering now?
You know, I lose track. But on that image that Bruce was showing, there were, I think, 8 objects, and there was one of them I didn't discover, Pluto. But all the other ones, all the other ones were mine.
You know, I asked you years ago, do you feel some kinship with Clyde Tombaugh, the Pluto's actual discoverer?
You know, I still am incredibly impressed by having gone through and found all these myself. I know how hard it was for me, and I had all the benefits of computers and robotic telescopes and digital cameras. He did all this stuff himself. I don't feel kinship with him. I feel sort of awe of him more than anything.
How about the rest of you? Do you think that, Pluto and its neighbors are any less interesting or significant because a group here, some humans, decided it's no longer an official planet? Jim?
Well, I have great respect for Professor Brown. I think we differ, and I differ from a lot of my astronomy colleagues in that, I tend personally to have a different definition of a planet, and I think about what an object is like intrinsically rather than necessarily where it is. And so I think of a planet as a place that has become round because of its self-gravity and mass, a place that maybe has differentiated into a core, a mantle, and a crust. Maybe it has an atmosphere, maybe it has moons of its own, like Pluto has 5, Pluto has a thin atmosphere. And it has had, all of the ones I consider planets have had an interesting geologic history. They were geologically active in some way. Internal heat has made things erupt from the inside or made the inside churn around. And maybe some of them are still geologically active today, like Io, or like our own planet Earth, perhaps Venus, perhaps Pluto. We'll find out whether there's plumes or activity going on there. So by my reckoning, and I'm a weirdo, there's something like 35 or 40 planets in our solar system. All of those, those beautiful not planets that we saw, I think of them as planets. Now that differs from the dynamical definition and all that, but I think that's how I think of them, as more of a geologist perhaps than an astronomer.
Mike, rebuttal time before we get to Linda and
Well,
Bruce.
no, I would say that what Jim has just told you is that I am the greatest planet discoverer in history. So who am I to argue with him?
Excellent. Mike Brown loves Pluto, and he completely agrees with me. This has been a great show. Can we just wrap it up?
Yeah, we're done for this evening.
You.
Thanks,
Good night.
folks. Linda?
I think it'd be interesting to maybe get the public to weigh in as well. I know that when the announcement first came out that Pluto is no longer a planet, my little nephew came up and he phoned me and he said, "Aunt Linda, how could this happen? What can I do to make Pluto a planet again?" So, so there's a lot of discussion, I think, and maybe since Pluto was a planet for so long, maybe it could get grandfathered into the mix.
Let's ask our full house here at the Crawford Family Forum in Pasadena. How many say Pluto is still a full-fledged planet? Okay, maybe not even half. How many are perfectly okay with it being a
That was my
dwarf
daughter.
planet?
She just voted for Pluto.
I think the dwarf planet has it. You've all read Mike's book, apparently.
I think it's close.
Okay. Well, you need to read Jim's as well.
Well, you know what's cool, Matt, is it doesn't really matter what we call it, right? What matters is so many people are interested.
Thank you.
This is hugely popularly interesting right now. People are thinking about the space program. They're thinking about exploring the worlds around us and learning about this little point of light that's become a real world. It's very exciting.
Bruce.
That was what I was going to say. It doesn't matter, bottom line. I mean, it obviously does. A lot of people care passionately. But fundamentally what matters is Pluto's an interesting world. We're exploring it, and we're going to learn cool stuff about it. You can call it a planet, you can call it a dwarf planet, you can call it Bob, but it's still interesting.
I think that's awesome. I couldn't agree more. You've already talked about this, but let's reiterate. There's nothing in the pipeline right now, no missions planned, not just to get to Pluto. There is at least one headed to Jupiter. It's going to get there in, what, a year and a half? Something, 2017? Yeah, right, that's 16. The Juno mission.
16, yeah.
Linda, you're probably the most experienced outer solar system explorer. Talk some more about that. Are we making a mistake?
Yeah, it's true, Matt, that after we have Juno and Cassini ended in 2017, 2018, in a sense you can think of the outer solar system going dark, that we don't have beyond the Europa mission anything else to go out and explore, visit the ice giants Uranus and Neptune, to continue the exploration that Voyager started. So this is indeed a problem. It takes a long time to get out there, and yet we have nothing beyond Europa in the pipeline.
Well, we don't really even have Europa yet officially.
This is true.
We need
Officially.
to continue to push for that and make that happen. Absolutely.
Fingers crossed. Mike, we've got some really, really big telescopes coming online. You're an observational astronomer. In fact, we've had a lot of those people who are building those telescopes on Planetary Radio. Why is that not the answer? Can those telescopes not take the place of actually sending a little robotic emissary out there?
I would say that the telescopes are critically important to our exploration of the outer solar system too, because what the telescopes allow you to do is explore the diversity of all the worlds out there. But what you really want to do is have a few detailed looks at a few places like Pluto, and then use the telescopes to look at all the other bodies out there and learn from Pluto what the rest of these objects are like. So only having spacecraft, I think, is a bad idea. You want the telescopes too, but only having the telescopes, you're going to miss out on the richness of the stuff that we'll be seeing over the next couple of weeks here on Pluto.
Bruce, in your little introduction to the mission, we forced you to go very quickly through what happens after this flyby. You mentioned in passing that as New Horizons heads out there into what we know as the Kuiper Belt, it may just have some other work to do.
Yeah, so assuming all goes as planned, they hope to add another flyby, which is of another Kuiper Belt object, and they've had a search program trying to find some. They have a couple of candidates, and they will decide between those fairly soon, and then try to redirect it. So basically, the spacecraft has all this momentum and a limited amount of fuel, and so where you can go is basically a cone past Pluto, and you need to find an object within that cone, and they found a couple, so it's much smaller, but that they will try to target.
Mike, I don't imagine any of your worlds are going to be in that cone.
No, it was even just a good bit of luck that any of them were at all. It took a while to find anything that was going to be there. So all the other large ones that I've been studying are just scattered all around the rest of the sky. So it'll take new missions to get to any of those other objects.
Tell us for a couple of minutes about some of those worlds that you found and what we know about them.
I can tell you for hours and hours, so you'll have to stop me. But
No, you can go ahead. Matt's fine with that.
Yeah, thank you, Bruce.
I think of them almost as my little babies. Each one of these objects is unique and has a little story of the history of the solar system in it. There's Eris, which is the one that's more massive than Pluto. We just found out yesterday that it's actually a little bit smaller than Pluto by just a few tens of kilometers, but it's still 27% more massive, which is interesting. So it's actually a lot more rock on the inside than Pluto is. They have had very different histories. I would love to get up close to there and see what's going on. Another of my favorites is Maki Maki. Maki Maki is kind of a transition object between Pluto and some of the smaller objects. It's got the methane and the nitrogen like Pluto, but it's a little bit smaller, so it's losing some of its atmosphere. The weirdest object that I think this is fair to say, the weirdest object in the entire solar system, and I'm willing to bet it's one of the weirder objects in the entire universe. I'm just going to go out on a limb on this one.
I don't know. It's a big universe.
It's a weird object, though. I'm telling you.
Go ahead. Prove him wrong.
It's Haumea. Haumea is it's shaped sort of like a football that's been deflated and stepped on. I used to always say that many years ago, and now when I say that, people laugh. But it's like a deflated football stepped on. It's spinning end over end. It's twice as big in this direction as it is in this direction, and 1.5 times in this direction. Spins end over end like this. Its outer surface is almost pure water ice, frozen water on it, and yet when we measured its mass, oh, there it is, it's the oblong one up there. When we measured its mass, we realized that it has the mass of almost pure rock. So it turns out to be a rock covered in this thin layer of water ice. It's got 2 moons going around it. Each of those looks like a little ice cube. And what's more, we have now found, so our original hypothesis was that it was this big object that was rock on the inside, ice on the outside, got smashed really hard by another object 4.5 billion years ago, started spinning, and that smashing would have cracked it open. All the ice would have gone flying away. And 2 of those moons that you see, those 2 moons are icy chunks that were left over. And in the meantime, in the last decade, we've now found about 15 other icy chunks that used to be part of Haumea that are now not in orbit around Haumea, but they're in orbit around the sun. They got smashed so hard. So it has this family of stuff trailing it in the same orbit. It's a fascinating object. It's my favorite name of any object of all the ones. They all have pretty good names, but Haumea is the Hawaiian goddess of childbirth, and in Hawaiian mythology, her children are all pieces of her that break off. So I just thought it was the best name that we came up with.
I'll stop you there, except I'd
No,
love
wait,
to
there's
get 30 seconds on Sedna, because that's, I mean, we call Mars the red planet.
Yeah, so Sedna is it's probably the coldest body that we know of in the solar system. It's on this 12,000-year orbit around the sun. It never even comes close to any of the planets. It's about twice, the closest it ever comes to the sun is twice as far away as Neptune is, and a little further than that, almost 3 times as far away. It shouldn't be there. It's one of these things which is really exciting. When you discover something that shouldn't be there, you have learned something new about the solar system. I think we've been debating for a decade what it means. I think we are closing in on how Sedna got in its weird orbit, and I am not allowed to tell you right now. But I'm going to tell you that wait a few months, and I think we know the answer, and we'll be talking about that soon.
Tantalizing. Okay. He's a good scientist. He's not going to do it before publication. That's the right thing to do. But you can hit him up afterwards. Maybe he'll take a $5 bill or something.
Yeah, 10 actually.
$10 is the going rate for a Caltech guy. We're going to pause for a moment now. We have about 10 minutes before we're going to go to the NASA TV webcast. But for now, I'm going to turn it just to Bruce and me. Normally, we would do this at the end of the show, but we're going to do it early tonight because we have so much great stuff ahead of us. And we're going to do the What's Up segment. Now, anybody's heard the show, you've heard this at the end of the program for almost 12 years. We do it live, as we're about to, and that means that you folks out there are going to get in on the trivia contest, the space trivia contest. You might just win a prize. But first, I will turn to Bruce and say, what's up?
Well, golly, Matt, Pluto's up, but you can't see it very easily unless you have a spacecraft or a good telescope, or a medium telescope. Anyway, what's easy to see, Matt, is we've still got Jupiter and Venus looking quite stunning in the early evening west, low in the sky, looking very, very bright. And in the south, we've got Saturn, Linda's planet, looking quite spectacular in its own right over in Scorpius. We go on to this week in space history, and in 1969, you may have heard of this, the first humans landed on the moon.
Yeah.
I'll tell you about it later, Jim.
I've driven the car of one of those guys.
And also, same day, July 20th, in 1976, Viking 1 became the first successful Mars lander.
What is it about July? Everything happens in July.
It's a party. We move on to, did you want me to? Why don't you help me out and say, random space fact?
On three. That'll make it better.
Okay. 1, 2, 3.
Random space fact.
All right, very nice. Pluto's moon, Kerberos, is named after the 3-headed dog that guarded Pluto's underworld, but really Hades' underworld. The Greek spelling Kerberos was used because Cerberus, the Roman spelling that would match the Roman Pluto, was already in use for an asteroid.
Wow. Okay.
All right, there you go.
I think that's going to come up. Actually, no, it doesn't come up again. I'll cut this out. That doesn't come up until next week. Sorry about that. On to the trivia contest.
All right, we asked you, when was the last... You remember that Pluto's orbit actually takes it inside the orbit of Neptune for a few years in each cycle. When was the last year in which Pluto was closer to the sun than Neptune? How'd we do?
Very well. We had a really good response to this one. This, because we're actually recording this on a Tuesday, and the deadline was just earlier this morning, we only just had time to pick the winner of this week's contest. Before we mention that winner, chosen by random.org, what is the answer?
1999. Not that long ago.
Yeah. Was when that was when after 20 years inside the orbit, it went back outside?
Right, and it'll hang out outside for another couple hundred years, so sorry.
All right, the lucky listener and entrant this evening who got picked by random.org is Brendan Frechette of Meadow Vista, California. He said, indeed, it was 1999. and that was when Pluto fell into, I love this, 8th planetary position, fell back into 9th 20 years later, except, of course, that now we only say there are 8. He says, love learning new facts and science from all at the Planetary Society. Keep up the excellent work. Love listening to you all every week, and thanks again. Brendan has gotten himself a fabulous Planetary Radio t-shirt, which one of you, or more than one of you in the audience, may win in a moment or two. But along with that, a 200-point itelescope.net account. iTelescope is the worldwide network of telescopes that can be accessed by anyone. And you can take pictures, send them to your friends. There are some really good scopes out there. It's worth a couple of $100 American, and we thank iTelescope for making that available. And I think we're going to offer that again.
I was just going to say we might want to go to the mission operations feed that they're showing.
Oh, we're seeing something else?
Yes. Technically, the signal is supposed to come back at 5:53.
Oh, let's go there now. Can we get to the satellite feed, and we'll pick up what's up later. I guess it came in early.
Kaplan is good.
Yeah.
Green is good. Yeah.
Ladies and gentlemen, I think we made it.
That's good. You gotta get that, man.
Okay, to
Look, New Horizons is entering the room.
as you get enough.
Wow.
Well, I apologize.
Subsystems, please report your status as you get enough data.
So you have the subsystems will be reporting their status.
Mom, this is RF on Pluto 1.
Go ahead, RF.
RF is reporting nominal carrier power, nominal symbol-to-noise ratio for the telemetry. RF is nominal.
Copy that, RF nominal.
Nominal is good.
Nominal.
That's exciting.
Woohoo! We like nominal.
Mom, this is Autonomy on Pluto 1.
Go ahead, autonomy.
Autonomy is very happy to report nominal status. No rules have fired.
Jim?
No
rules have fired?
They haven't violated any flight rules. They haven't gone on anomalous situations, no safe modes, anything like that.
Go ahead, CNDH.
CNDH reports nominal status. Our SSR pointers are where we expect them to be, which means we've recorded the expected amount of data.
Sweet.
Copy that. Looks like we have a
lots
good
of
data
images on
report.
board. Lots of data on the computer.
Mom, this is GNC on Pluto 1.
Go ahead, GNC.
GNC is nominal, all hardware is healthy, and we have a good number of thruster counts.
Copy that. GNC is healthy.
Sweet. So the spacecraft must have moved the right direction when it was supposed to and used as much fuel as they were expecting.
Mom, this is propulsion on Pluto 1.
Go ahead, prop.
Propulsion is nominal. Tank pressure is 176.8.
Copy that. Propulsion system is nominal.
Yeah.
Mom, this is power on Pluto 1.
Go ahead, power.
Power system, all telemetry is nominal. Hardware is healthy.
Copy that. Nominal for power.
Mom.
Power's good too.
Are we geeks or what? Power is nominal.
Mom, this is thermal on Pluto 1.
Go ahead, thermal.
Thermal reports nominal. All temperatures green.
Copy that. Thermal is nominal. All temperatures green. Okay. PI, Mom on Pluto 1. We have a healthy spacecraft. We've recorded data of the Pluto system, and we're outbound for Pluto.
Yeah. Let's hear it. That's it. That's what we wanted to hear. That's Alan Stern, the principal investigator. What a moment for this whole team, but especially for Alan. Oh, little interruption.
We can send a spacecraft to Pluto.
Can't get a good signal from the internet.
That's a really good point, Matt. There's thousands of people that probably made this happen. You know, from, people at the Applied Physics Lab, Southwest Research Institute, other labs around the country, around the world.
Thank you for getting us to take the feed. We might have missed this altogether. Yeah. That came about 15 minutes earlier than we had been told in the NASA schedule. Hell of an accomplishment. Linda, what that made me think of, and others can get in on this too, when you did orbital insertion at Saturn, and everything, again, had to work right. Those engines had to fire for a long time. Does it make you think of that?
Right. It's similar kind of nail-biting feeling that, of course, that burn happened behind Saturn, and so we had to patiently wait until Cassini came out and sent that signal, and there was just relief, a sense of relief, tremendous joy. We were in orbit around Saturn.
Let's see if they're talking to us here. Can we bring the audio back up, Dave? And
I didn't know who that was.
There we go.
Marching in the room when that happened. That was a slightly happy mission principal investigator, Alan Stern, who has just poured so much time, investment, heart, soul, like so many people on the New Horizons team to get to this point. Mark, I guess it's kind of hard to be impartial sitting here to watch this, but your thoughts on this?
Well, I can't say, how proud I am to be part of the team and of the team for all the efforts they've made building the spacecraft and testing it and flying it for over 9 years to get to this point. It's really an amazing accomplishment. How often do we unlock the secrets, of a new world? We did that today. How cool is that?
We had a chance to see there too briefly NASA Administrator Charles Bolden and Associate Administrator for the Science Mission Directorate, John Grunsfeld, in mission operations with Alice Bowman. I mean, a tremendous day for the New Horizons mission. So weird that we're back here. A little more of the atmosphere in there, but we're going to reset here at APL for a media briefing, approximately around 9:30. We want to give the participants time to get here for mission operations. And tomorrow, we expect our first post-flyby looks at the Pluto system sent back from a healthy and very much alive New Horizons spacecraft. I said, bring on the Discovery.
All right, I guess we can take it down, Dave. Jim, there are these moments of terror, of anxious, almost horror, aren't there? Getting to Mars, too.
Getting to Mars, getting to Saturn, going into orbit by a planet, flying by somewhere new. You feel like dancing and throwing up at the same time. It is just
Can we get video?
No, but that's why we do it, right? We get hooked on this, and the public gets hooked on it, and it's so great to be able to share this in real time. I mean, it could have been a failure. Rockets do explode on launch pads, and bad things happen to spacecraft. I've been involved in a couple of missions that didn't work, that weren't successful, and it is sickening, and so many people have spent time and effort on it. So when they do succeed, it is just a precious and wonderful thing.
Bruce, weren't you on stage with Bill when we had those 7 minutes of terror, curiosity going down to
I was indeed.
Mars? Yeah.
I was completely relaxed.
Like hell. That was very similar. Maybe even more exciting.
Well, you don't want to pick between your
No,
children.
I'm not going to pick favorites. But
All right. Or do you? No.
But you've been to a bunch of these.
I have, and we've had a lot of fun, and this is one of the things that we enjoy doing as Planetary Society, is bringing people together for these live events that crystallize part of what planetary exploration is all about. So we did the Curiosity landing, as I say, going all the way back to Neptune flybys of Voyager and farther back. Planetary Society's been doing this, so it's a long tradition, and it's a fun time, and things hopefully go well. And in any case, you share it with everyone, and now we get to the other really cool part, which is the science and the data and good stuff coming back.
And we're going to talk more about what it takes and why it's important to see these missions continuing and what it takes to make that happen. And it really has more to do with Washington, D.C. than JPL or Caltech or APL or anything like that. We'll get to that in a few minutes. But since we were underway and we're almost done with it, let's go back to What's Up very briefly and give you your chance to win some of those prizes. First of all, I want to remind you that the answer was 1999 was when Pluto went back outside the orbit of Neptune. And we do get all kinds of fun answers, responses from other listeners who entered the contest as well. David Dearden in Mapleton, Utah said, yeah, 1999. Maybe that's why Prince was partying. We're going to party like it's 1999. And then we did have a reference to say, somebody answered it correctly, Setapong in Jamaica, New York. The question, of course, was when was Pluto last closer to Earth than Neptune? Pluto the dog has always been closer to Earth than Neptune. So there you go. All right.
That's true.
Let's go ahead and do the contest for the people who are here with us at the Crawford Family Forum in Pasadena.
All right. Got some questions? Am I going to attempt to throw T-shirts at them?
Please do. Now, we got some other stuff, too. We'll just start with T-shirts. Warm up the arm, please.
Okay. All right. Good news. A lot of these questions have been answered during this our time up here, so hopefully you were paying attention. So raise your hand, and then someone will come by with a microphone. What 5 spacecraft are leaving the solar system, never presumably to return?
Don't shout it out. We're going to let Liz here from KPCC pick the first person to answer. Way over there. Hi there, sir. Introduce yourself.
Leonard Daly, Voyager 1 and 2, Pioneer 1 and 2, and New Horizon.
You got it.
That is incorrect.
Voyager 1 and 2, Pioneer 1 and 2, and
New Horizons. That is incorrect.
Okay.
Because I'm just that much of a stickler.
Because I missed part of what he said. Let's go to somebody else over on this side. Hi, sir. What's your name?
Paul Hoover from Long Beach. Voyager 1, Voyager 2, Pioneer 10 and 11, and New Horizons.
That is correct.
Got it.
Sorry.
So close there. All right. He's warming up the arm. Let's see if this is pretty far back in the room. Oh, if it opened up like a parachute. Otherwise, it might have been okay. Let's do one more shirt.
All right. We did not, I don't think, cover this. For every 3 orbits that Neptune makes around the sun, how many orbits does Pluto make? They are in a resonance. For every 3 orbits, Neptune, how many times?
We're going way over here. Hi, now there is an outer planet scientist there. You're disqualified, Tom. That's Linda's husband. Yes, sir.
Uche Akatobi. It's a 3-2 resonance, so 2 times.
Yes, that is correct.
Nice work.
Right, lay it on me.
Here it comes. Oh!
It got lost in the sun. Man, I need those flip-down shades.
Very nice, though. And when you say they're in resonance, they really have a relationship, right?
Yes, they have a relationship, but it's predicated on the understanding that they never actually come near each other. Which, yes, it's the outer system restraining order. So it is designed, so they will never run into each other, but they do feed in this order, this resonance, and there are a lot of other objects in that 3-2 resonance, as well as some other resonances like 2-to-1 and other such things.
But I'm still stuck on the restraining order that gives how many astronomical units you have to stay away from the other person. Anyway, one more of those for the shirt. I hope you've got a few more of these, because then after this shirt, we're going to get to some other special prizes.
Oh, golly. Okay, who discovered Pluto? First name required.
Here it comes. Don't say it out loud.
Matt Vandermillion, Clyde Tombaugh.
That is correct.
Nice work. There you go. All right, let's see if this one can be dead accurate.
See if I'm getting better.
Just like New Horizons reaching Pluto, absolutely perfect accuracy there. All right, we are now going to go to
T-shirt
something.
Flight is nominal, catching is nominal.
We have. I don't think that they can be pitched, so you're going to have to come up and get it after the show.
Oh, I think I can frisbee those.
You want to try? Well, this pin has sharp edges. I don't know.
All right.
This is
Liability.
a Light Sail tote bag. Light Sail, the solar sail project that was successfully flown by the Planetary Society not long ago at all. We have all kinds of goodies in here. There is a nice light sail pen, a Planetary Society pin, like I and Jim are wearing up here. Bruce forgot his. This is going to go to the first person to correctly answer Bruce's next question.
All right, name all 5 of Pluto's known moons.
Ooh, good one.
I'm going to challenge you.
That's a good prize. It deserves a tough question. We got somebody who wants to give it a shot. I don't see any other hands, so we give him a chance. Oh, way over there? Oh, he's... And I don't want to see any smartphones out either. Hi there, sir. What's your name?
My name's Bob Black. I'm from Ventura County.
Okay, name them.
Sharon, Hydra, Kerberos, Nix, and Styx.
That is correct.
Not
Very nicely
bad.
done.
That man has just won himself a light sail tote bag. We're just like public radio. We have tote bags now. Okay, another.
And you will be asked for a significant donation after you collect. Sorry, but you are always welcome to give. All right. What rocket launched New Horizons?
Fastest probe ever to head away from Earth. Yes, sir, your name.
That is correct, the Atlas V.
Atlas V. Light sail tote bag for that man. And here is the last of the light sail tote bags. So we'll make this the last question, and then we'll go back into discussion and be talking with Emily again in about 10 minutes. Bruce?
All right, this one's going to be a little tricky. Of the spacecraft leaving the solar system, which one is currently going the fastest relative to the sun or relative to the Earth?
Relative to the Earth. That's a good way to put it. Okay, way over on that side. We haven't been there in a while. Way out on the end. We'll get a microphone over to you. And what's your name, sir?
I'm Joe. I'm from Pasadena, Voyager 2.
No, that is incorrect.
All right, we're going to grab somebody else here in just a moment. We had a little, how about this guy right up here? Young guy up in the front here. Wait a minute, wait. What's your name? What's your name?
Jonah.
And?
Voyager 1.
That is correct.
Nice work. All right, as I said, those of you who've won a tote bag, come on up here at the end and we will hand it to you.
So I'd like to explain that one because New Horizons did leave the Earth-Moon system at the fastest speed of any spacecraft, but Voyager 1 actually picked up and retained the most speed. So the sun gravity is slowing the spacecraft as they go, and Voyager 1 has a higher energy of its spacecraft nodule.
All right, we need to come up with a question for the listeners at home. Please don't shout out the answer, but you can enter if you like.
All right, as of today, we're going to go unofficial and unofficial. What is the unofficial feature name being given by the New Horizons team to the dark feature that some have unofficially called the whale? Go to planetary.org/radio contest. Get us your entry.
And you have until Tuesday, the 21st of July. That's Tuesday, July 21st at 8 a.m. Pacific time, and we will get you a fabulous Planetary Radio t-shirt, as you just saw thrown out amongst you, and another 200-point itelescope.net account. Okay.
All right, everybody. Go out there, look up in the night sky, and think about cartoon dogs. Thank you, and good night.
Woof, woof. Give us a good bark.
Ruff, ruff.
He does a great Scooby, too.
What's up, Matthew?
He is the Director of Science and Technology for the Planetary Society, Bruce Betts. All right, we have a few more minutes now before we'll check in with Emily again, who I bet is still jumping up and down there at APL. And I want to talk about the kinds of things that we're seeing, the surprises that we have already seen from this mission. Aren't surprises kind of the rule when we have a mission like this, whenever we get a good close-up look at a new body? Linda?
Absolutely. Whenever we look at a close-up to a moon at Saturn, a good example would be Enceladus, we always find something unexpected, and that's part of the fun of the exploration there.
Jim, it's a rule.
Yeah, and you know, we look at these early images, and people are going, oh, it kind of looks like Triton, maybe Iapetus with that dark stuff, and we haven't even talked about Charon, right? I mean, Pluto's got this giant moon relative to its size, very different composition. what's going on there? All of that, all those questions are sitting in a hard drive 3 billion miles away. And we have the worst dial-up connection anybody has ever had in the history of the internet, and we have to get all of that information back to the Earth. That's why it's going to take up to a year to get all the stuff back.
Yeah. Mike, you get a little bit more immediate gratification, although I shouldn't really say that because you could spend years looking for objects, right?
It's a very different way of doing things. You know, I get to go out to the telescope and go do something this very night if I want to, and so I don't have to wait that 10.5 years or 9.5 years. But you're right, sometimes I spend 9.5 years looking. Our survey of the outer solar system, where we found all these large objects, was about a 10-year project. We're just starting a new one, looking even further, that will probably be another 10 years. So I stay busy.
Can I ask Mike a question?
I'm not going to answer.
Please. No, it's a
You really offended him.
No. How many big objects are predicted to be in the Kuiper Belt? What's the size of the population overall?
In the Kuiper Belt, which in sort of the main region of the Kuiper Belt, which extends from just beyond Neptune to maybe about 50% further away, we've probably found the biggest ones, the brightest ones. But we now know that it extends much further out, and we're just now beginning to explore there. I would say that it's likely in this next region that we're just starting to explore, there are probably, I'm going to guess 30 or 40 objects the size of Pluto, and many, many more that are smaller, and even some that might be a good bit larger.
So we're going to need 30 or 40 more names of planets. Wow.
They're not planets.
Okay.
I want to follow up on that. Would you be shocked if in your time out there at the telescopes and comparing images, if you found something that was Earth or Mars sized? You just don't think that's going to happen?
No, I actually do think it's going to happen. But I can't talk about it.
Oh, shoot.
I can talk about it a little bit, which is, if you look at Sedna, the one that we talked about that has a 12,000-year orbit, it's a very elongated orbit. So it's right now almost as close as it ever comes to the sun. And when we discovered it, we could only have seen it for about 200 years. After 200 years, it's so faint that we wouldn't see it. So 200 years out of a 12,000-year orbit is about 1 in 60. So that's where we come up with these numbers. There's probably something like 60 objects the size of Sedna, which is about half the size of Pluto, a third the size of Pluto. 60 of those, maybe we got a little bit lucky. Maybe there are only 30 and we found one, or maybe we're a little unlucky. There are 90 and we only found one. But there must be many of those. And so if you assume that there are 60 objects the size of Sedna, and you try to then guess what the largest object out there is, you say that's where you come up with the 20 or 30 the size of Pluto, maybe a couple that are couple times bigger than Pluto, 1 or 2 that are 4 or 5 times Pluto. So you're getting up to Mercury, Earth, Venus. That wouldn't surprise me at all.
Wow. A lot to look forward to. Oh, yeah. We've got hopefully about 3-4 minutes before we go back and check in with Emily at the Applied Physics Lab. I want to follow up on what Bill started to talk about and what it takes politically, economically, to make missions like this happen. It's not easy, is it, Jim?
No, it really is a decades-long process. I mean, the New Horizons mission came from previous attempts to mount a mission like this, going back to the 60s, as I mentioned earlier, but more recently trying to get NASA interested in that, trying to get the scientific community interested in it. The scientific community ranks the priorities of various missions through these things called decadal surveys. You take a snapshot every decade. What is the most important science to get done? What are the missions that NASA should mount, in what order? And that's where the Mars Sample Return mission comes from. That's where the Europa mission comes from. That's where Galileo and Cassini came from, these big flagships. And then you try, and maybe you have, the economy is good and NASA can afford a little bit of a budget bump and your mission gets in. Or maybe the economy is in the tank and everything gets cut and there's no way you can do your mission, and you miss the celestial mechanics opportunity to do the flyby you needed to do. So many things have to line up. You know, Mike and I are involved together in we really are friends, actually. We're involved in a proposal for, what did you do? In a proposal to try to do a mission, a space telescope mission, actually, for the outer solar system as part of the Discovery program. And, you know, who knows what, we were competing with 28 other mission proposals, 27 other great mission proposals out there. One will get selected. So, you know, it's a very competitive process. The politics, the finances, the celestial mechanics, the science, all has to be right.
Linda, you had some anxious moments not too long ago. They had nothing to do with the function of your spacecraft, but whether you were going to be given the money to see this mission out to its end, right?
Right. Once a mission finishes its prime mission, then you get into this period of extended mission, and you have to write a senior review proposal. We've had to write 2 so far with Cassini, and each time we had to wait to see if we'd get enough funding to keep the mission going. And so, fortunately, we did. We don't have to write any more senior review proposals. Our mission is good through September 2017.
And just very briefly, what happens in 2017? Because it's going to be another big event. We'll have something probably even bigger than this.
Well, in September 2017, we're actually going to take the Cassini spacecraft. We'll be diving in between the orbit of the planet and the rings. And after 22 orbits there, then putting the planet into Saturn. We'll get a nudge from Titan and actually go into Saturn's atmosphere, burn up just like we did with Galileo. And we're doing this to protect Enceladus and Titan, 2 worlds that we know have liquid water oceans, and Titan also has methane lakes on its surface. So it's for planetary protection. So we know the day, September 15th, 2017, that will be the end of the Cassini mission. We're almost out of fuel, and so that's why we're going to end the mission.
So was it the fuel, or was it so you didn't have to write another senior proposal?
Yeah, that's close. That's close, yeah.
So it makes me think of the book 2010, Attempt No Landings Here. Hit Saturn instead. I think we have a little bit of a shaky connection, but I think I got a thumbs up. I got the sun in my eyes. Are we good for talking to Emily? Emily, we're bringing up the monitor here. Hang on just a second while we warm up. Not just Emily, but Bill Nye, the science guy. Welcome back, folks.
So good to see you all, Mike. Greetings.
All right, so tell us about the moment there that we got word back from New Horizons.
That was no big deal. No, people went nuts. They went crazy. Every time the mission operations manager, Mom, Alice Bowman, said, thermal reports okay. Fuel pressure okay. It was cool. And so then she reported after, there's 6 categories? 6?
Something like that.
Yeah. She reported we have a healthy spacecraft outbound from Pluto, and then Alan Stern, the principal investigator, came in, high fives all around, hugs and kisses. It was cool. The crowd went wild.
We saw a little bit of that from here because we were, thanks to Bruce, because it came early, we were watching the crowd just after the announcement took place. Emily, your thoughts?
The one that was music to my ears was the one about SSR pointers, and SSR stands for Solid State Recorder. That is the device that holds all of that precious, precious science data. And it said that they had as many as they thought they should. That means they took all of their data products, every single instrument on the spacecraft, all the thruster firings also happened as planned. So both the pointing and the data products are on there. That means that there's a lot of science to be done. And as soon as I saw that, I jumped up and I hugged a whole bunch of scientists because they have jobs for the next 5 years now.
There'll be, really, everybody, there will be hundreds of scientific papers generated every year from this thing, I'm sure. And not that it's about generating papers, it's just trying to give you a sense of how many data were collected. It's a giant thumb drive,
Yeah.
way out in space, way out there.
A 4-gigabyte thumb drive.
Yeah.
Emily, you told us earlier 3 images that we should be able to see within a few hours. What do you expect from those images, and how good are they going to be?
Well, there's actually, there's 2 different downlinks that are happening tomorrow. We should get nice portrait pictures of Charon and another one of Pluto that will look very similar to the one that we already saw, but not quite the same. And that's going to give us a 3D view so that we can see what those landforms are. We'll also get our first portrait views of Nix and Hydra, the 2 smaller moons, and we'll get 3 very high resolution pictures of the surface of Pluto so that we can see what those landforms look like up close.
All right, so what's happening now at APL? Has anybody started to go home, or are they just hanging out and celebrating?
Oh, God, no, they're just hanging out. And as a matter of fact, I have to get downstairs in 7 minutes for the press briefing where everybody's going to go, yay, hooray, we did it. and then celebrate, and then probably, to be honest, go drink a couple of beers before the night is over.
I know, shocking. Bill, you're the science guy. This is pretty cool. You're in your element, aren't you?
Oh man, I mean, just keep in mind, everybody. I mean, I go way back with this mission. I mean, who hasn't wondered what Pluto's like? And we made the case to U.S. Congress in the year 1999 and the year 2000 in the traditional Planetary Society advocacy kind of way. And the mission got funded. And I mean, it's just extraordinary. To me, as an engineer, if I may insert this, Emily, you can bite my head off. But part of the reason this thing succeeded, in my opinion, which, as you know, is correct, is it did a bunch of remarkable things, but it didn't do too many things. Like, it was just managed. It was managed very well. It had just the right number of instruments, just the right amount of data storage. And they made a decision that turned out to be a great one. We're not going to send everything back in real time. We're not going to try to take that on. We're going to play the hand we're dealt, way out there at 30 astronomical units, 4.5 light hours, geez, away, and it just made, I guess, for a very reliable spacecraft that's just returning extraordinary information.
I'm going to let both of you get back down to that press briefing and rejoin the celebration there at APL. Please, if you run into Alan Stern or any more of the team members, tell them you have a room full of very excited people here in Pasadena and a lot more watching us online. Thank you both very much. I'll see you back at home.
Thank you, and thanks, panelists, for being here tonight. Carry on.
Emily Lakdawalla and Bill Nye, the science guy.
Change the world.
All right, we are nearly at the end of this very exciting evening, this celebration of New Horizons at Pluto. I want to try and get some closing thoughts from the folks who are here with me on stage. And Bruce, I'm going to stick you with that first since you're first in line.
I am excited.
Which is true. You know, that's how he sounds when he's really, really excited.
No, it's borderline emotional, which is very problematic for me. I mean, this literally is something that since I was a small child, I wondered, hey, what's Pluto look like? And it's kind of profound that now we kind of know. It's funky after decades of waiting, and I'm sure a lot of people have experienced that. So it's good, and I'm looking forward to the next year and a half of data coming back.
Jim,
I'm also very emotional about this too, and I still have butterflies in my stomach. Okay, spacecraft made it. Now we need to get the data down. But this has been, for me, it feels like there's a series of bookends going on here, right? And this year we saw the end of a very successful mission at Mercury, closest into the sun, and now the beginning of a very successful downlink at Pluto, way out there, right? The entire solar system encompassed within this year. And also, this mission is bookending this half century of space exploration. It's the 50th anniversary of the Mariner 4 flyby of Mars.
Today is that anniversary.
Which was the first planetary flyby out at beyond Earth's orbit. And so what we've seen today is the end of the first phase of exploring our solar system, at least flying by everything that everybody knows about. That happened today. We just finished it. There we go. Boom, right there. Okay. And
people just stopped discovering things.
It's so cool. And so it's the end of that phase, and the end, an ending is always a beginning, right? And what that means is now we're starting the next phase, and the next phase is doing more detailed missions like Cassini at Saturn, like Galileo at Jupiter, getting orbiters out to Uranus and Neptune, understanding what ice giants are like and how they're different from gas giants, getting more landers and rovers to Mars, landers and rovers down to Venus, Mercury, asteroids. What we're going to see now, and now that we've finished this part, now we do this part, and that starts getting more complicated, more detailed, bringing samples back, spending time in those environments, getting to really know them. And what's beyond that is getting people out there. And I'm really excited about that.
Linda, your turn.
Well, I've been really thrilled to be a part of being here tonight and just sort of witnessing, as Jim said, sort of the bookends of the end of this half century. And also I wonder, as we understand our solar system better, what does that mean for the other planets around other stars and those other systems? Are they like our solar system? Are they different? Are we unique? And now we have just more information that we can use as we can get better and better views over the next decade or two of those other worlds around the other stars.
Hundreds and hundreds of other planets discovered largely by the Kepler spacecraft. In fact, this week, or if you're listening to this on the radio, last week's Planetary Radio conversation about the smallest of those exoplanets, we now know its mass and size. We may only be a few years away from being able to find biosignatures, signs of life on some of those planets.
Or imaging what those worlds look like, the clouds, maybe even the surfaces, and starting to understand worlds beyond our solar system.
Mike, you get maybe not the last word, but the second to the last word.
It's funny. So this night seems like, you know, the culmination of this 9.5 years, and we're all clapping and things are going on. And yet, to me, this is, we don't know anything about Pluto yet. We've gotten just the smallest little hints of what's there. And so I feel like tonight and tomorrow are the beginning of Pluto exploration, not the ending phase. So I am thrilled to see what's going to be there on Pluto. I'm actually as excited, I'm maybe more excited about Sharon than I am about Pluto. I can't wait to wake up tomorrow morning and see what has been released. And I think that will be happening every day for the next couple of months here. So it's just going to be great.
And Mike, I look forward to having you back on Planetary Radio when you're ready to make that announcement. And all of you who are past guests on Planetary Radio, Bruce, who's there every week, I very much look forward to having you back on the show. They are all multiple episode appearances on Planetary Radio, and I hope you will tune in as well. Bruce Betts, Jim Bell, Linda Spilker, Mike Brown, please help me thank them one more time for joining us this evening. So we are out of time, but Planetary Radio will be back next week and every week, just as we've been doing for nearly 12 years. You can learn more about the show at planetary.org. While you're there, you might want to check out the special New Horizons Pluto Encounter section, along with Emily Lochtawalla's great blog and Bruce's Random Space Facts. We tweet at Explore Planets. I'll be back here on the Crawford Family Forum stage on Wednesday, July 22nd. That'll be not for the Planetary Society, but to host KPCC's next Science People tomorrow. Our topic this time will be relativity and how it has changed our lives. As always, and they have hosted us many, many times, we thank KPCC, Southern California Public Radio, for its outstanding support of this evening's show. Special thanks to Janice Watchie-Hurst, Liz Brown, Dave McKeever, Jason Georges, Haley Waters, Ashley Alvarado, and the managing producer of live events here at KPCC, John Cohn. Lastly, thanks to all of you for watching or listening this evening. You were part of history by being here. We close with this delightful video from the Galaxy Girls with All About That Space. The Galaxy Girls Save Pluto. I'm Matt Kaplan. Clear skies, everyone.
Space. Because we're all about that space, outer space, go Hubble. We're all about that space, outer space, go Hubble. We're all about that space, outer space, go Hubble. We're all about that space, outer space, space.
Yeah, it's pretty clear, Pluto's a planet too. That dwarf can orbit like it's supposed to do.
With 5 moons that we can trace, and all the right ice in all the right places.
I see New Horizons working that shutter stop just to rub it in. Come on now, make it stop. If you love Pluto, Pluto, just raise them up. 'Cause every inch of Pluto's perfect from the bottom to the top. Yeah, my mama, she told me don't worry about Pluto's size. Shoo up, up, shoo up, up. She says scientists like more planets to hold inside. Yeah, Pluto, Pluto. Huh. Yeah, Pluto, Pluto. No, it won't be no Milky Way gas giant ball. Shoo up, up, shoo up, up. So if that's what you're into, then go ahead and move along. Because you know we're all about that space, outer space. Go NASA, we're all about that space, outer space. Go Hubble, we're all about that space, outer space. Go SpaceX, we're all about that space, outer space. I'm bringing Pluto back. Go ahead and tell my other scientists that. No, I'm not playing though the world ain't flat. But I'm here to tell ya, every inch of Pluto's perfect from the bottom to the top. Let's go to outer space.
All systems are go. The liquid hydrogen tank inside the external tank is now at the proper flight pressure. T-minus 1 minute and counting. The booster joint heaters are being deactivated at this time.
I'm so excited for this rocket to reach Jupiter. No. All right, here we go.
5, 4, 3, 2, 1.
Discovery now making one last reach for the stars.
And that as well is on YouTube. The producer, person behind it, Sue Schmidt, is here somewhere. Where are you, Sue? There she is, right back there. Thank you very much, Sue. Again, thank you all for coming, and have a great Pluto evening.